Hi there. Today I'm going to talk about data science, and who is better to talk about data science than our own Nicholas Renotte. Nick is a data scientist working at IBM. He is a data science rock star and has a social presence across YouTube, LinkedIn, and Twitter. He has an amazing YouTube channel where he provides tips, practical tips to get started on data science, AI, and deep learning. He is also the inspiration behind my own YouTube channel. So, welcome, Nick.
Thank you so much. What a great intro, Saga. Thank you very much.
The very basic question that I have in my mind is there are so many different terms when we talk about data science. And as a non-data scientist, I use data science, AI, machine learning, and I always use them and interchange them when I'm talking with my customers. So are these terms the same thing, or are these different things? Or what is the meaning of each of these terms, and whether I'm right in using them, interchanging them and using them?
Yeah, I think the community has sort of agreed upon pretty standard definitions for most of those terms. Now, that being said, there is a ton of jargon when it comes to the data science, machine learning, deep learning, AI space. Broadly, if you think about it in a set of concentric circles. So think about, you've got this really big circle on the outside. That's what we call AI. And this is really all about how we teach computers to think without explicitly programming them. So if you think about how we used to code in the old days, we still code now, we typically give a computer, or we actually write some rules. We then pass some data or pass some information, and then we get answers. So say, for example, you've got an if statement. You might say, you might have a picture and you take a photo of a particular frame, that picture comes in, and then you've got some logic, and you might go, if the picture is of a dog, then print out it's a dog. If the picture is of a cat, then print out it's a cat. So that's traditional programming. If we flip this on its head a little bit, we've got machine learning, data science, or we've got machine learning and deep learning, really. And this is where we pass historical data and historical answers to be able to generate rules. So this means that we don't need to explicitly teach a computer how to do something. We're able to teach it through historical information. And that's where machine learning and AI comes in. Now, when we talk about AI, it's all to do with how we teach these computers to think. Typically, in the current state of affairs, we're looking at narrow or specific AI and general AI. So general AI is when everybody's thinking of Terminator and just all seeing and all being sentient computers. We are still a little while away from that. What we are seeing a lot of interest in is specific AI. And this brings me to the second concentric circle. So if you think about the big circle on the outside as being AI, if we draw a smaller circle inside of that, we can take a look at machine learning. And machine learning is really the application of those specific rules that we've actually gone and taught our computers. So some practical examples of machine learning. Banks are using it a lot to predict churn. So we know that it costs more to acquire a new customer than to retain an old customer. So it'd be a great idea if we tried to predict which people were likely to leave before they left. And that's a great application of machine learning. We can also use it to do things which are a little bit more altruistic. We can actually use machine learning to predict people that are at risk. So we can actually try to help them before something bad goes wrong. That's sort of machine learning in a nutshell. There's a lot more. Obviously, I've simplified it. Then inside of that circle, we've got deep learning. And this is the application of neural networks to machine learning tasks. So a lot of the cool stuff that you're seeing in machine learning is happening in the deep learning space. Things like speech to text, text to speech, image detection. If you've heard about GPT-3, where you've got generative text or text generation, that's all in the deep learning space. And then, all right, so imagine you got your three circles. So you got AI, you've got machine learning, and then you got deep learning. Now I want you to cross a circle over all three of those, and that's where data science comes in. So data science is the practice of doing those three things. So there is, think of an engineer. An engineer does engineering type tasks, but there are specific engineering type tasks. A data scientist will do things like build AI models, build machine learning models, and build deep learning models. So it's the practice around it, and it spans a little bit more. So it's all to do with how do we process our data? How do we interrogate our business to find out the use cases? And it takes it a little bit further. So a little long-winded, but yeah, hopefully that's provided a little clarity on the different terms that definitely pop up.
That is such a great explanation of how what you mean by AI, machine learning, deep learning, and where data science fits into all these three different practices that we have, or technologies that we have. So thanks, Nick. I'm already learning something from my first question itself.
Awesome.
So let's go into the second question and a little bit into details about what you as a data scientist do when you have to create a machine learning model. So what are the steps that you use to create a model, and what are the tools that you use for creating the machine learning models?
I think the absolute number one thing that you have to do when creating any type of analytics is to speak to the end users. So often we get so caught up by technology and we get so caught up by all the amazing things out there that we forget to ask the people, hey, what is it that you're trying to achieve? Sometimes we'll go and apply some technology, and I'm guilty of this as well. But sometimes we'll see a new technology come out there, like deep learning. When I first got into data science, I'm like, I would just throw deep learning at absolutely everything. I'm like, could be the smallest problem, and I'm like, I'm gonna get 2 GPUs and I'm gonna train a deep learning model. But that's not always the case. Sometimes there are simple solutions to simple problems, or even complex problems. But yeah, the first thing that you need to do is you need to speak to your users and find out what it is that they want to do. Then the next most important thing is to get some data. So I think if you're not collecting data for things which are important to your business or things which are important to your life, then you're missing out on a huge opportunity. So collecting your data and ensuring that you've got that stored somewhere is going to ensure that if you want to go and apply some cool technologies like machine learning, like data science, like deep learning in the later stages of your business, or in the future, or even now, you're going to have that data available. So once you've got that, then it's all to do with exploring your data, preparing it, so ensuring that you've got clean data, and then starting the modeling process. Now, in terms of the tools, there are a whole heap of them out there. But my particular favorites are Python. So I use Python for open source programming to build machine learning models. But then you don't really need to be a coder to go and get started with this. So we've actually got tools inside of Watson Studio and Cloud Pak for Data, which are IBM's flagship data platforms, to actually build machine learning models. So say, for example, I wanted to try to do what a bank is doing and predict churn. And it doesn't necessarily need to be banking clients. It could be your clients. It could be consulting clients. It could be whatever. We can actually take a data set which basically shows features which we think are important to a customer staying or leaving, and whether or not those historical customers have stayed or leave. And we can actually throw them into a tool called AutoAI, and in 3 clicks, and this is not me bragging, but literally 3 clicks, and you can have a machine learning model built, you can have it explained, and if you want, you can even deploy it. You can also open up the code if you really want to see what's behind the scenes. So that, in a nutshell, is probably how I'd go about it, Saga.
Yeah, and so thanks for that. And you touch based on AutoAI, and it looks like a tool for people like me who are not data scientists but who still want to go and create machine learning models. So with AutoAI, is that really, like you said, it's just 3 clicks? Is that really how it is? Okay, is it?
Yeah, it is. I mean, I've got a YouTube video on my channel. You guys can see it. I'm not lying. A couple of clicks and you're going to have a machine learning model. But yeah, you're completely right. It is all aimed at empowering the citizen data analyst, data scientist, data engineer. Because not everyone needs to be a data scientist. I think sometimes the people that are going to be the most powerful when it comes to generating insights from a business are going to be the people that work in that business. If you are a doctor, you're probably going to be better at building medical machine learning models because you understand the factors which are going to influence a particular outcome. If you are an electrician and we were to have to build a particular model as to when a transformer was going to degrade or break, you're probably going to have the best insights visually, but also through tabular data as to when that particular transformer may blow. So being close to your data is just important as empowering yourself with the tool. So AutoAI sort of takes the fear of having to write code and build stuff from scratch and really helps you use some of these emerging technologies.
That's awesome, Nick. What I'll do is I'll go and look at that video that you have on AutoAI, and I'll put the link to that video in the description of this video. So thanks for that. I've also heard a lot about bias when data scientists talk about machine learning, and for me, bias is very high level word where we just talk about bias in real life, right? When I'm biased towards one person or biased towards one of the technology. But what does that really mean in a machine learning model or in data science field?
Yeah, I mean, we probably don't have enough time to delve into it into huge amounts of detail, but it can mean a number of things. So it can mean picking the data which is only representative of a specific group of people. So say, for example, we were to try to build a machine learning model to predict, let's think of a good one, predict hailstorms and whether or not those were going to impact car premiums. Well, if we selected data where there were a ton of hailstorms and we knew that there was going to be damage, and then we went and applied that to a different region or to a different group of people, we don't necessarily know that the data is representative of the particular sample that we're going to go and apply it on. Another thing that we tend to talk about is fairness. So whether or not the data is actually generating fair outcomes. And sometimes this can be due to a number of factors. So ideally what we want to do is try to tease out that bias and not necessarily eliminate it completely, but we need to be cognizant that that bias could potentially be there. Now, once you have identified that, we can actually go about mitigating that bias and trying to level the playing field. Now, it's not always going to be perfect. Sometimes we can try to level the playing field and change outcomes depending on whether or not we've got bias in our predictions or whether or not we've got it in our data. And certain fields don't even allow you to have certain professions don't actually allow you to have certain fields in your machine learning models because there is too much of a risk of bias by including certain factors. So I know gender isn't allowed to be included in certain financial or insurance-based models for that very reason. But being cognizant of it and at least identifying it, using tools like the open source tool, which is Fairness 360 or Open Fairness 360. And we've also got another tool which we actually use quite a fair bit to show it, which is OpenScale. So OpenScale sort of sits on top of your machine learning models and is not eliminating that bias unless you ask it to, it's identifying it. So every single time that we generate a prediction, we're able to see whether or not we're getting fair outcomes. And let me explain that a little bit more. So let's take our banking example at the moment. Well, actually a slightly different banking example. Let's say we were going to build a new website for this particular bank. And this website had a bunch of fields which allowed you to input some information and go and apply for a loan. Now, behind the scenes, when you would enter that information, there would be a machine learning model which takes all those fields and determines whether or not you're low risk or high risk. So based on whether or not you're high risk or low risk, you might be approved for a loan, or you might be rejected for a loan, or you might be approved for a loan with a higher interest rate or approved for a loan with a lower interest rate. Well, when we do things like that, we need to ensure that we are generating fair outcomes for people. There's certain fields that we don't want to be unfairly disadvantaging people on. For example, you don't want to be discriminating on sex. You don't want to be discriminating on age. You might not be want to be discriminating on disabilities or socioeconomic factors. So we can actually track that model. So say, for example, we get a prediction. If we have a particular group that we want to ensure that we're not unfairly disadvantaging, we can actually track that particular group to ensure that we're not giving them unfair outcomes. So say, for example, I get a monitored group come through, let's say young people. So let's say 18 to 24-year-old goes and applies for the loan, gets rejected and gets into the high risk category. What this tool will actually do is actually change that field. So it would change the age, it might change some other features to see whether or not it was age itself which generated an unfavorable outcome. Now, based on that, we can determine whether or not the model is fair or not. And if it is found to be unfair, we can actually mitigate that and change the outcome. So that ideally helps to level the playing field a little bit.
That's great, Nick. I think you went, although it's a complex, or we need to explain it in more details. I think you went into a fair amount of detail to explain how we can mitigate bias and have fairness in the model. So we talked about, we started our discussion with what is data science, AI, machine learning, deep learning. Then you talked about different steps and tools that you use in building a machine learning model. We talked about the bias and how we can get rid of it. I also hear a lot about operationalizing machine learning models, and I'm hearing that that's something which is very important today for most of the organization. So can you put some highlight or explain what do you mean by operationalizing machine learning model and why is it so critical?
Yeah, I can definitely talk about that. So put yourself in this scenario. So you invest a sum of money into some developers. They go and build you this amazing widget. Now, this widget is really shiny. It looks great. You're like, wow, this is so cool. But you never put that widget into the production floor. You never actually go and build that widget and go out and sell it or use it. That is sort of a shortfall, right? And that is almost what we're seeing when it comes to data science. People are going out there, they're doing these random acts of digital and they're building these awesome prototypes, but they're never putting them back into their business and actually using them for their benefit. And when we talk about operationalizing machine learning and data science and deep learning, really we're talking about taking whatever model it is and actually integrating it back into your systems and making it usable for everyday users. What a lot of data scientists tend to code in, and I myself do this, is we tend to code in a tool called Jupyter Notebooks. But Jupyter Notebooks in and of itself is not a way to go out and consume a machine learning model if you're just an average user. I'm thinking, whenever I'm in these scenarios, I'm always thinking of my parents. I couldn't give them a Jupyter Notebook and ask them to use my machine learning model. They would be like, what on earth is this? But if I gave them an app, for example, and said, hey, just plug in some information here and hit the button at the bottom, they could consume that. And I could operationalize my machine learning model that way. So that is what we typically talk about when it comes to looking at operationalizing machine learning. But it's only the first phase. So let's take a look at this in detail. So we've gone to develop this widget. And in this case, our widget is our machine learning model. I sort of alluded to that. Now what we might do is we might take that widget or take that machine learning model and we could deploy it a bunch of ways. We could actually take it, we could turn it into an API, which could then integrate into our mobile app. We could take that specific model, and I don't have my Raspberry Pi floating around, but we could actually take it and put it on an embedded device. So we might put it on a Raspberry Pi or a Jetson Nano, and we could actually use that on the factory floor to detect whether or not we've got defects in products going off the manufacturing line. It's all to do with taking that model and taking that insight that is effectively encapsulated in that model and pushing it back out into the business. Now, the next thing about operationalizing is that you need to be able to monitor and govern those models. So let's say my parents go and use the app on my phone. They go and plug in some information and it's trying to predict, obviously this is going to be biased, but it's trying to predict their age. You plug in a bunch of information, hit predict age, and it comes back with a wild number. It says that they're, 4 years old. Well, you know that there's probably an error with that model. So this is where the second phase of operationalizing machine learning and data science comes in. We need to be able to take feedback from users out in the field that are using our models and ensure that we can go back and retrain them on new information to ensure that we have accurate predictions and that the predictions that our models are still relevant to our business. Because if I go to let's say, for example, a 50-year-old and my machine learning model predicts that they're 4, we already know that that's wrong. So maybe we need some more information. Maybe we need to do some more data processing. Maybe we need to train our model for longer. These are all things that it's really important to consider, because when we do use machine learning and data science and deep learning, it's not a one and done process. It is going to be iterative, because just as your business evolves, these models need to evolve as well.
This is amazing, Nick. What I've learned in the last 15 minutes is so much. I've learned so much about data science. We have touched base on really a broad range of subjects, and I know we can go in details about a lot of those things, but unfortunately we don't have time today. But it was a great session talking to you and getting some knowledge from you. Thank you, really thank you for taking time and speaking to me about data science.
No problem. Thanks for having me.